Hello students, how are you? In today's tutorial, I am going to talk about series and parallel combination of resistors. Whenever you are using tap water, you need to control the amount of water flowing out of it. To control the amount of water flowing out of it, what do? You control the knob. If you control the knob of the water, you can control the amount of water easily. Similarly, in a given electrical or electronic circuit, we need to control the amount of current. Since in a given circuit, the current is directly proportional to voltage. That is, voltage upon current equals to constant, or voltage equals to resistance into current. By increasing the value of the resistance, we can decrease the amount of current flowing through the circuit. Similarly, by decreasing the value of the resistance in a given circuit, we can increase the amount of the current flowing through the circuit. Thus, in an electrical or electronic circuit, by controlling the value of the resistance, we can either increase or decrease the value of the current. So, how to increase the value of the resistance and how to decrease the value of the resistance, that is what the today's topic is. You see, this is an electronic circuit. In this electronic circuit, there are so many components, and every component do not require same amount of current. To alter the value of the current, we need to use different value of the resistors. And here are the LEDs. Here are the LEDs are there, and these LEDs, this IC, and these are the different components. They all require not same amount of current. Some of them require more current, some of them other are required the less amount of the current. So in an electric or electronic circuit, we need to control the amount of the current. To control the amount of the current, we have to change the value of the resistors. We have to change the value of resistances connected in the circuit. To change the value of the resistance values in a given circuit, we need to study series and parallel combination of resistances. In today's tutorial, I will tell you how to obtain expression for series combination and parallel combination, and what exactly the series and parallel combination stands for. What is the meaning of the series and parallel combination? That I am going to tell you. And I will, at the end of this video, will also distinguish between series and parallel combinations. Suppose I got a resistor here. The name of the resistor is R1. Now the second resistor I am having, that is equals to R2, and the third resistor, that is equals to R3. Like this I got the three resistors, R1, R2, R3. Now what you do, there is an end-on connection, that is a first resistor and second resistors are connected by wire here, and the second resistor and third resistors connected by wire like this as shown here. Now one starting end of the first resistor is connected to positive terminal of the cell, and the last end of the R3 last resistor connected to negative terminal of the battery. If you connect this way the resistors, then we call it as a series combination. Of resistors. So in series combination, there is a end-to-end connection. That means end of the first resistor connected to the starting of the second resistor, and so on. That is a series connection. One more important aspect of series connection, suppose the battery voltage is a V volts and the current coming out of battery equals to I amperes. So current coming out of the battery equals to I ampere. Now this current will flow through R1. The current will flow from here, and it will flow through the R1. How much current is flowing? The same current I is flowing. And the same current will also flow through the R2. And the same current will flow through the R2. The current will flow and come back to the battery once again, come back to the cell once again. But in the series combination, the voltage at R1 and voltage at R2, the voltage at R3 are not same. Say voltage at R1 equals to V1 and voltage at R2 V2 and voltage at R3 equals to V3. We technically say voltage dropped across R1 is V1, voltage dropped across R2 equals to V2, and voltage dropped across R3 equals to V3. So in series combination, what to understand? In series combination, same current flows through every resistor, and voltage is not same. It is different from R1 to R2 and R3. It depends upon the value of the resistance. But in series combination, if you wish to correlate V1, V2, V3 with the supply voltage, then supply voltage equals to V1 plus V2 plus V3. That is, if you add all the voltages of R1, R2 and R3, the voltage across R1 and voltage across R2 and voltage across R3, if you add all of them, then you will be getting the supply voltage. Therefore, V equals to V1 plus V2 plus V3. Now, let us imagine if I remove all the resistors and replace by a single resistor and with the same battery. And suppose the total of R1, R2 and R3 equals to R. Let us imagine like this. And the current coming out of the battery equals to I and supply voltage is V. In that case, by using the Ohm's law, V equals to IR. That means R is a total resistance of R1, R2, R3. This total resistance of R1, R2, R3 is called equivalent resistance, called as a equivalent resistance. So we imagine that total of R1, R2 and R3 equals to R. And how to calculate V1 now? The V1 can be calculated by the Ohm's law. V equals to I into R1. V1 equals to I into R1, because voltage equals to current into resistance. Similarly, how to calculate V2? The V2 equals to I into R2. And after that, V3 equals to I into R3. So we got here V1 equals to IR1, V2 equals to IR2 and V3 equals to IR3. Now we already know that the total value of the resistance V equals to V1 plus V2 plus V3. V nothing but I into R. So I got I into R. And what is the V1? V1 nothing but I into R1. What is V2? I into R2. And what is V3? I into R3. Now, after this, what you do here? You take the common. What common? You can take RHS. You can take I is the same. So taking the I as the common, R1 plus R2 plus R3 are left in the bracket. I and I get cancelled. We get R equals to R1 plus R2 plus R3. So R1 plus R2 plus R3 added together, we get the R total resistance of the circuit. This total resistance is nothing but called equivalent resistance. R equivalent equals to R1 plus R2 plus R3. It is being a series combination. We can also express it as a RS equals to R1 plus R2 plus R3. It is just merely the different mode of presentation, either the R equivalent or the RS. That is a series combination. What you do? You add all the resistor values, all the resistances, then you will get the equivalent resistances. The equivalent resistances resistance is nothing but a single resistance which is obtained by removing all the small resistor values and replacing all the resistor values or resistances values by a single resistor. Then it is called as a combined resistance or equivalent resistance. Now let us move to obtain the expression for parallel combination, and let us understand what exactly the parallel combination is. Now, parallel combination. Suppose we are having three resistors. Let us say first resistor R1, second resistor R2, and the third resistor R3. The starting end of all the resistors connected together. End point of all resistors connected together. And from here we give the supply to the battery and other negative terminal to the other end of the combination. Let us call first resistor as a R1, second as a R2, and third as a R3. And the supply voltage equals to V volts. And the current flowing through the source equals to I. Here I flowing out of the battery as soon as it come to the point A. Let us say A is the starting point and B is the end point. When the current comes to the point A, it divides into three parts. Some current will go through the R1, some other amount of the current will flow through the R2, and the rest of the current will flow through the R3. So let's say the amount of current flowing through the R1 equals to I1, and current flowing through the R2 equals to I2, and current flowing through the R3 equals to I3. Thus, in parallel combination, current is not same. Current is not same. The different amount of current will flow through every resistor. The amount of current flowing through the resistor will depend upon the magnitude of resistance, that is the value of the resistance. But in parallel combination, the voltage across each resistor, that is at R1 the voltage equals to V, at R2 the voltage equals to V, and the voltage will appear across R3 is also V. So in parallel combination, the current is not same, but same voltage appears across each resistor. The voltage is not changing. The amount of current flowing through the every resistor will be changing. So that is what the parallel combination is. In parallel combination, if I add all the three currents, then I must get the supply current. So supply current is how much? I. And all the three currents addition, that is I1 plus I2 plus I3. In parallel connection, if we add all the currents at R1, R2 and R3, then we get the supply current. Therefore, relation becomes I equals to I1 plus I2 plus I3. And by using Ohm's law, V equals to IR implies I equals to V upon R. That means how to find I1? I1 equals to V upon R1. How to get I2? I2 equals to V upon R2. And how to get the I3? We can get I3. I3 is equal to V upon R3. Now let us imagine that R1, R2 and R3 are deleted, and in that place we replace it by a single resistor R. The single resistor R is replaced such that the total of R1, R2 and R3 will be nothing but equals to R, that we call as equivalent resistance, with the connected to the same supply, and the amount of the current flowing I is also same. So how we can relate here? We can relate that I equals to V upon R. I equals to V upon R. Now we are having the relation I equals to I1 plus I2 plus I3. So we can replace I by V upon R. We can replace I1 by V upon R1, and I2 can be replaced by V upon R2, and I3 can be replaced by V upon R3. So we get here V upon R. Here the numerators are same, so taking common, so I get V is common, so 1 upon R1 plus 1 upon R2 and plus 1 upon R3, and both side V and V get cancelled, and this nothing but 1 upon R equals to 1 upon R1 plus 1 upon R2 and 1 upon R3. So this R is nothing but called equivalent resistance in parallel combination. So it can either be represented as R equivalent, R 1 upon Rp equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So P for parallel combination. So either of the expression you can utilize. Some people write like this also, R eq, then write P here, and for the series combination R equivalent and S here. So there are the different modes of representation. Don't confuse yourself. So just here I got R eq. R 1 upon Rp equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. This is a expression. By using this expression, we can find out the equivalent resistance in parallel combination. So let me summarize the thing. In series combination, here is a R1, R2 and R3. So Rs equals to R1 plus R2 plus R3. And in parallel combination, we got the 3 resistors here. Not necessarily 3, you can have the 4, 5, 10, n number of. 3 for the sake of simplicity I have taken. You can even have the 2 resistors, you can have even 10, 100 resistor as well as. So here I got the 3 resistor in parallel. So equivalent resistance 1 upon Rp equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. By using this expression, easily we can find out equivalent resistance in case of series combination and parallel. The first one is a series and the second one is a parallel. Now let us distinguish between the series and parallel combination. Now let us summarize the things. In series combination, the equivalent resistance given by Rs equals to R1 plus R2 plus R3, and the total voltage of the supply voltage can be obtained by adding all the voltages at individual resistors. Therefore, V equals to V1 plus V2 plus V3. And in series combination, the resultant resistance is higher than individual resistance. And in case of parallel combination, 1 upon Rp equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3, and the total current, the current will divide at each resistor. Therefore, total current I equals to I1 plus I2 plus I3, and the resultant resistance is smaller than the smallest resistance. So this is what the distinction between series and parallel combination. I hope you understood the concept of series and parallel combination. And thank you for watching this video. And remember to subscribe my channel and like the video, share with your friends. Meet you again with another video another time. Till then, bye bye. See you again. Wish you good luck.